Am I audible?
Yes, ma'am. Good morning, ma'am.
Yes,
Good
ma'am.
morning,
Good
ma'am.
morning.
Good morning.
Good morning, ma'am.
Morning, ma'am.
How are you all?
Good, ma'am.
Good, ma'am.
Fine, ma'am.
ठीक है मैम.
ठीक है. So, how was yesterday's lecture? Are you getting?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yes, ma'am.
Yeah. All lectures, I think motives or our lectures means you have to get in a very simpler way. Means topics are tough, maybe, but you have to understand it's actually topics are very easy. All terms are very easy if you think or understand nicely. Okay. So I hope my PPT is visible. Graph
Yes,
theory.
ma'am.
Yes,
Yesterday we
ma'am.
have started a new topic, a new unit of discrete mathematics, that is a graph theory. Everyone is aware since childhood they are aware about the graphs, but actually what is the means graphs and images or pictures? What is the difference? Difference is graphs is focused on the vertices and edges. If something relationship is there, suppose there are, you can see this picture. If you see this picture, there are 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 10 nodes. So if suppose there are 10 members in the family, how you are not in a family, a very big family that is said to be a combined family. So how people are may related to each other. Maybe you are taking the topics of relation, you have to explain first of all, then you have to make these edges. So if you are talking about the taste of the family members, you are talking about the interest of the family members in the games, so how family members are interrelated to each other, so it will be shown by the edges. If you see these edges are not connected, so it means suppose this member of the family and that member of the family both are not having same type of interest or same types of hobby, so if you are giving the relationship name hobby. So edges are representing the relationship between two vertices, whether they are related to not each other or not. Okay. So, and vertices is specifically denoting some people, place, hobby in which you are interested, name of the persons or name of the cities, name of the places, name of the phenomena, whatever you are doing there, or you are drawing the graph for that, you can give the name vertices, and different phenomena are when related to each other, then it will be shown by an edge. So we have seen graph is nothing but the collection of vertex set and edge set. Capital V is denoted by for vertex set and capital E for edge set. Total number of edges, total number of vertices. Okay, I hope it is very clear here. We have discussed about the applications. We have touched actually, not completely I have discussed here. I cannot say completely it was covered. It will be discussed later. So we have discussed the concept of, because you have to understand all the terms that involves in the graphs. So self loop and parallel or multiple edges. Parallel edges means I think everyone is clear about the word parallel. So these are, you can see the parallel edges. These are the parallel edges. So because starting and end point of vertices are same. Simple and multiple graph. If graph has no loop, no parallel edges, simple graph, otherwise multi-graph. Null graph, weighted graph, finite and infinite graph, adjacency or incidence. That is not very much important. You have to memorize or remember. If you understood, then okay. So these terms are not for you. Adjacency and incidence for your means further learning. The degree of vertex, that is very important. You have to understand if graph is given for any purpose. If you want to calculate degree of all the vertices, you can calculate, but you have to keep in mind you have to calculate loop twice. So we have calculated that also, and different variety of vertex according to vertex, the name of vertex, and labeled directed graph. Yes, we have touched the part directed graph. If directions are given, and directions are given, then what comes in the mind, how to calculate degree of these vertices. So if you are going to calculate degree of vertices, so you can see there the some from this vertex, some edge is going from this vertex and some edge is coming towards this vertex. So how to calculate degree? So there is a concept of in degree and out degree. In means incoming, out means outgoing edges. That is all about the edges. So in degree of vertices, how to calculate the number of incoming edges towards that particular vertex, जिसकी आप in degree calculate करें और जिसकी आप out degree calculate करें, the number of edges with vertex B as a, or you can say number of outgoing edges from V. So towards V and from V, that you have to keep in mind, and you are going to calculate in degree and out degree very easily. Nothing tough here. Okay, so that was the yesterday's topic. Now we have to see if any student is facing problem to calculate these points and whatever degree or them. So at the end of this class, we can discuss. Okay, so that topic is not related to this. So we can see here the concept of complete graph. How we can say a graph is a complete graph. So very clearly, if degree of each vertex, students, degree of each vertex is n minus 1, when graph total number of vertices is n, okay, in a simple graph means no parallel edges, no loop, okay, keep in mind, no parallel edges, no loop, and अब उस graph के vertices कितने हैं, how many vertices, n vertices. So what you have to check, if degree of each vertex is n minus 1, so graph is said to be the complete graph. Once again, just imagine, I am not showing anything. If graph have 8 number of vertices and each vertex, जितने भी vertex है 1, 2, 3, 4. If each vertex degree is 7 with n vertices, 8 vertices, 7 degree of each vertex, then that graph will be the category of complete graph. Okay. If n number of vertices are 5 and each vertex, suppose there are जितने भी vertex हैं, okay, 5 vertex हैं, all 5 vertices are having 4 degree, all equal. So that type of graph is said to be the complete graph. Okay, we'll see an example. This is a graph, yes, any graph, any type of vertex and collection of edges said to be a graph, yes. How many vertices? 2, n is equal to 2 here. So what should be the degree of each vertex? Only 2 vertices here. So degree of each vertex is 2 minus 1. That is 1 and 1. It is a complete graph, everyone, according my definition. Yes, it is a complete graph, and a specific name for complete graph in books are given, that is K1, K2, like this. So 2 vertices, complete graph, so K2 name of this graph is K2. Once again, everyone see, this is a graph, yes, this is a graph. How many vertices? N is equal to 3. For being a complete graph, n minus 1 degree of each vertex. Degree concept, everyone clear who left yesterday class? Degree means where direction is not given. How many edges passing through this node? So degree is 2. How many edges passing through this node? Degree is 2, degree is 2. So you can see n is equal to, n was 3 and degree of each vertex was 3 minus 1, 3 minus 1. So this is a complete graph with 3 vertices. The specific name is K3. Okay. Now students, how many vertices here? 4. N is equal to 4 here. This is a complete graph or not? We have to check degree of all vertices. 1, 2, 3. Degree of V1 is 3. 1, 2, 3. Degree of V3 is 3. 1, 2, 3. Degree of V3 is 3. V4 is 3. So this is a category of complete graph. This is a special kind of graph, complete graph, and you can say this is K4. Again check everyone. 1, 2, 3, 4, 5 vertices. Degree of V1 is 1, 2, 3, 4. 4. Everyone can check. If I am wrong, let me know. Degree of all 5 vertices, I can see there are 4, 4, 4. So this is a complete graph. Everyone clear?
Ma'am, for the second vertex.
Here. 1, 2, 3.
Ma'am,
3 edges
V4
first.
is not
Same for
connected to
the
V2.
Sorry?
Ma'am,
Ma'am,
V4.
only V1, V5 and V3 has 4 vertices and the rest of all have 3 vertices.
Okay. I think I have
Not
missed one
connected.
edge. This?
Yes, ma'am.
Yes, ma'am.
Sorry. Thank you.
Ma'am, this
And now
definition
to?
of yes, ma'am. Ma'am, this definition of complete graph is only for an undirected graph, right?
Right. That is a written here, simple graph as well as simple graph means undirected graph. So some top terms are for undirected graph where direction is not given. Some definitions will be for directed graph.
Okay, ma'am.
Okay, because that time if we cannot talk about degree, we have to talk for in degree, out degree, and that will make it complicated. Okay. So if I am using degree word, so it means degree here is for
Undirected.
undirected. है ना? If I am specifying in degree or degree, so it will. So that I have made actually in class. Here you can see this is the only with one direction. Degree of this K1. How many number of vertices? Vertex
One.
is equal to 1 and the n minus 1 means 0 here. So degree of this is, so this is name is K1. Is it okay everyone? K2, K3, K4, K5. Yeah, I was trying here to make K5. So there. So that is the concept of complete graph. At least note down the word complete graph, everyone. And topic is clear. I will upload video. No need to note down. Just focus here. Regular graph. And now everyone, when I will tell you any other type of graph, you have to find out differences that I told earlier. That means complete graph and regular graph. So that आपका concept और वहाँ पर solid होगा. So I told you now complete graph. Now switch to the regular graph. What is the definition? If each vertex of a graph has the same degree as every other vertex, the graph is regular graph. Now you will say, ma'am, यहाँ पर भी वही था. Yes, complete graph is a regular graph, right? But there was only one condition extra, total number of vertices and then degree of each vertex should be n minus 1. But here is no restriction. Okay, don't know how many total number of vertices, but degree of each vertex should be same. All vertices having the same number of degree. So that type of, जो भी आपकी degree होगी, that will said to be that degree regular graph. Means you can see 1, 2, 3, 4, 5. 5 number of vertices. That's it. Here I am not going to search 5 minus 1 degree of each vertex is 4, 4, 4, 4. No. Here I am just going to check how many vertices are having how many degrees. So this vertex have degree 2. 2 number of this vertex have degree 2. This vertex have degree 2. This vertex have degree 2. This vertex. So all vertices have same degree. And what is the degree? Degree is 2. So this is said to be the 2 regular. So only just by seeing name you can identify degree of that particular graph was 2. That's why 2 regular graph name is there. So this is a 2 regular graph. Agree everyone? Now check for 3 regular. This is 3 regular or no? So here 1, 2, 3, 4. 4 number of vertices in this particular graph. I'm not concerned with n minus 1 degree. I am going to check 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. All vertices have same number of degree. So here this is a 3 regular graph. Maybe it is a complete graph or what? I'm just checking for regular graph concern. 1, 2, 3, 4, 5, 6, 7, 8. 8 number of vertices. Okay. Degree of each vertex is 1, 2, 3, 4. 4. 1, 2, 3, 4. 4 edges passing through this node. 1, 2, 3, 4. So this type of graph is the example of regular graph and 4 degrees, so 4 regular graph. I hope no doubts here. Very simple terms I'm taking here. Now complement of graph. Just try to understand the very simple specific meaning of complement of graph means complement of that. Means something you have and complement means you don't have that particular thing. So let G be a graph. Now we have to understand G be a graph. So you have to imagine some nodes and edges. The graph complement of the graph G is the graph whose vertex set will be the same. आपके पास वर्टेक्स सेट है वो सेम होंगे, सेम, and in which vertices are adjacent as the vertex set of G. Both vertex set will be common, and in which vertices are adjacent if and only if they are not adjacent in G. So student, I hope you are not understood. Yeah, this is my graph. Okay, try to understand from my this example. Okay, vertices are here. Suppose this is E1, this is E2, this is E3, this is E4, this is E5 and E6 in this graph. So in this graph name is G. And now suppose I need to find the complement at that graph. So there also vertices will be same 1, 2, 3, 4, 5. Where whatever V1, V2, V3, V4 and V5. Here also in the complement and graph, vertices will be the same. But one more thing, if E1 is present here between V1 and V2, that should not be, definitely not be in G complement. That graph means जो connection आपको यहाँ दिख रहे हैं वो connection आपको यहाँ नहीं दिखने चाहिए. For each and every edges, it is implied. Okay. It implies for each and every edges. Suppose E1, E2, E3, E4, 5 we are present between these nodes. So between those nodes, it should not be present in G complement. Let's try to make it clear. Suppose this is a graph. Okay, very simple. 1 and 4 के बीच में edge नहीं है. Okay, between 1 and 2, yes, there is an edge. Between 2 and 3, edge is there. Between 3 and 4, edge is there. But in G complement, where edges are present in between the vertices, in those vertices edges should not be present in the G complement. It can be denoted by G complement or G bar, some books. So here student, vertices are same, vertex sets are same. Here V is having 1, 2, 3, 4. This is the name of vertices. And edge set is what? Suppose this is E1, this is E2. You can give, otherwise you can write the edge name 1, 2, edge name 2, 3, edge name 1, 4, like that. So edge set is E1, E2 and E3. 1, 2. And now you can see in the G complement 1, 2, 3, 4 here, between 1 and 2 edges are not present. Okay, between 2 and 3 edges, edge is not present. Between 3 and 4 edge is not present, but wherever edges were not present, there we can see the edges. So between 2 and 4 edges were not present, edge was not present. I can see between 2 and 4, between 1 and 3. Understood clearly? If you understood, please try to note at least 1 or 2 words so that after 1 month, if you see your notes, or okay, it's okay if you are going to watch video. So that is a very simple concept. Wherever edges were not present, there you have to put edges. Again, see, this is a graph H. And you can note down the vertices. Same vertices should be in the H complement. But edges were not between 1 and 2. You can put between 2 and between 5 and 4. You can put between 1 and 4. Edge was not there. So you can put between 3 and 5. You cannot see edge. You can put. Otherwise, remove all the edges. I hope pencil will work nicely here for complement of a graph. Okay, student, got it? Got it?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Good. Now try to understand. Now topic is going to be a little bit complex. Bipartite graph. Bipartite graph. Try to understand the meaning of the graph. Bipartite. All graphs have their own meaning. Okay, what is the meaning of bipartite? Bi means two, partite means partitions. Okay, so let G, E, B, comma, E be a graph. Okay, vertex set, S set. G be a bipartite graph if its vertex set B can be, listen, G be a bipartite graph if its vertex set V can be partitioned into two non-empty disjoint subsets. That is very important. Non-empty होनी चाहिए वहां पर vertices. Disjoint means, I think students you have read subsets or sets. Disjoint V1 and V2 are disjoint if they don't have any common element, right? Got it? So disjoint subsets V1 and V2 such that each edge has one end in V1 and one end in V2. Okay, try to understand. G be a bipartite graph. If its vertex set V, suppose this is a vertex set V, it can be partitioned into two non-empty disjoint subsets V1 and V2. So उसको two part में divide करना है such that each edge has one end in V1 and one end in V2. Means अगर next जो आपके ग्राफ बन रहा है उसका one end जो भी edges है, how many edges in the graph? So total number of edges in the graph. So one end comes from V1 and other end should come from V2, like that. So you have to do partition like this. If edges are there, so edges का one end V1 से आए and second end should come from V2. So this is E1 suppose. Got it? So if G a graph, then we can divide the vertex set into two disjoint subsets. Disjoints mean there should no common vertices. Okay? Each edge, अभी देखो यहाँ पर. This is a graph G. Okay? Vertex set V is equal to, suppose I giving the name. This is A, B, C, D, E, F, G. So what is a vertex set? A, B, C, D, E, F, G. And I'm going to say this is a bipartite graph because I'm able to partition V into two non-empty disjoint subset V1 and V2. So V1 I can see A, comma B, comma C, and V2 D, E, F, and G. And student, this is disjoint. Disjoint है because there is no common vertices altogether, right? And each edge, how many edges? One edge, two edge, three edge, four edge. Each edge. So E1 is a edge, and what is the E1 end points? Means initial and terminal points AD, right? What is the edge E2? Suppose I am giving the name. E2 is BG. What is the name of E3? E3 I given the name here. So end points of E3 is C and F. Okay. What is E4? End points, that is C and E. Any other? One,
Yes,
two,
ma'am, there are
three,
5 pages actually.
5 edges. No? I think DF I missed. Yes, E5. So student, what is the meaning of this definition? I am able to divide the vertex set into two partitions such that all edges, one end of edge is come from V1 and other is come from V2. अभी देखो A, B, C, D. A, B, C. One end from V1 and other end of this edge is from V2. Try to understand. Is it clear, everyone? This is the bipartite
ma'am.
graph. And it is very complex if you are going to read different books. Follow any book, one book.
Ma'am,
Yes.
can bipartite graphs be directional?
Directional means what you can say. Directional is there. So then you have to check direction. So here direction doesn't matter.
Okay.
Okay. I'm talking about only the edge. Okay. So here
Yes,
for definition purpose, direction not matter here. Okay, everyone got it? I am writing whatever I have written now. If you will write this thing, and after 1 month, if you are during your exam, if you see, then that time definition will. Otherwise, most of the students used to be confused for my experience. I'm telling you. Okay, so note down this, and then you will get clear if you are reading after some times also. So now next example is, suppose this is, and try to make you clear with this example, student, to yourself. Make you clear. V is actually here 1, 2, 3, 4, but it has been partitioned into V1 and V2. I am making some graph. Check this is
Ma'am,
bipartite or yes.
ma'am, so only a 1 point graph will be a graph which can never be bipartite. All
This graph,
other
this
graphs,
graph you are saying.
yes, ma'am.
Hmm,
Ma'am,
good
all the
question.
other graphs are always going to be
Yes,
bipartite.
because there is actually definition is not fulfilling. Na?
Yes, ma'am.
Good question. So now students, if you are agree with this graph, if not agree, then you ask me. Otherwise, I'm drawing one more because this is an important point of view because you can get to check this is a bipartite or not. So there should be no confusion. I hope my graph is correct. Check student vertex set of this graph. This is a bipartite graph or not. If edge is there, you have to check. One end of that edge should come from V1, other is, suppose name is given V1, V1. This is small V1 and V2, you understand like this. So V1 and V2 here. So here V1, V2, V3, V5, V4. From edges you can find vertex set V6 and then you can check your definition. So V1 have these number of elements V1, V3, V5 and V2, V4, V6, V7. So from vertex edges I can find, now I'm going to write V1, V3, V5. And V2, V2, V4, V6 and you can check V7. ओके सो आप ऐसे चेक कर सकते हो V1, V2 edge is there, V3, V6 edge is there, V5, V7 edge is there, and V3, V7 edge is there, V5, V4 edge is there, and both are coming from one vertex from one end is coming from other vertex set. Right, student? Everyone? Now for this, you can check, suppose V1 is here, 1, 2, 3. I'm not able to see screen if anyone is typing something because I am full screen. I have done full screen here, 4, 5. So now you can check it is bipartite or not. I'm telling you my method. 1, 4 means 1 is coming from here and 1, 4 edge is there. Now see other edge, 1, 5. If I'm guessing this is correct vertex set, then it is okay. 1, 5. So 1 and 5, 2 and 5, 2 and 5, 3 and 4. If edges are there, then it should come from first and second one. So 3 and 4, yes, 3 is here and 4 is here. So this is the example of bipartite graph. Got it, everyone?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Everyone? Now,
Yes,
one
ma'am.
thing you have to notice. एक चीज notice करना है अभी. There is no condition, means all vertices are connected from each other, from V1 and V2. अभी यहाँ पर देखिए, 1, 2, 3 edge vertices are in V1. Everyone listen why I'm telling you, because it depends on, it is for next definition that I am going to tell you. This is a bipartite graph, yes, because the vertices are coming from first and edges of each edges are from first vertex set and second vertex set in vertices. Okay. Now you can see here 1 and 5 are connected, 3 and 4 are connected, but it is not mandatory here. All edges of all vertices of this vertex set should be connected to all vertices of this. Means 2 and 4 are not connected, 3 and 5 are not connected, 3 and 5 is not connected. So this type of conditions will be going to apply for complete bipartite graph. Because a complete bipartite graph is a bipartite graph with bipartition V1 and V2 in which each vertex set of V1, that is important, each vertex of V1 should be connected to by an edge to each vertex of V2. Means for complete bipartite graph, I am just giving you example. It should be connected from here also. It should be connected from here also. It should be connected means all vertices should be connected. So means it should be 1 should be connected to 4 and 5. 2 should be connected to 4 and 5. 3 should be connected to 4 and 5. Like this type of example demands complete bipartite graph. Yeah. See. Example of complete bipartite graph, and complete word is there, so it is denoted by K33, K34. One vertex set number of vertices and other vertex set number of vertices. You can see here. So student, for complete bipartite graph, if you see vertex set here V1, V2, V3, 1, 2, 3, 4, 5, 6. 1 is connected to 4, 1 is should be connected to 5, 1 should be connected to 6. Important definition. 2 should be connected to 4, 2 should be connected to 5, 2 should be connected to 6 by an edge. Okay, 3 should be connected to 4, 3 should be connected to 5, 3 should be connected to 6 by an edge, and same for 1. You can see if it is there, that is the not example of only bipartite. This is a complete bipartite graph. Here you can see some edges, means here 1, 2, so 1, 4 was present there, but 1, 3 was also present, and here 2, 3 was present, and 2, 4 is also present, right? So you can say this is a complete bipartite if this is possible. And here also you can see this is connected to this but not connected to other one, but all definitions will follow here. You can see here 1, 2, 3 first vertex set, 4, 5, 6, 7 second vertex set, and you can see 1 is connected to all other vertices present in second vertex set, 2 is connected to, you can check student if anything is doubtful. So all vertex set should be connected to each and every second vertex set elements. So that type of complete bipartite graph is denoted by K, M, comma, N. M is the first vertex set number of element, and second N is the second vertex set element. Okay, I want to give you one more example for complete bipartite graph. Students are going to check I am correct or not. Yeah, my graph is now complete. Everyone check this is a complete bipartite graph or no? Not. I think the way I am making this graph, you can understand. This is a complete graph, bipartite graph. So two more examples for complete bipartite graph. A very interesting example. I like this example. This is like a star, a ring. This is K15. I think you can understand why K15. One vertex set that is having a very single element. Another vertex set is a, so this is a K15. Example of complete bipartite graph. So can I proceed to next topic? Made it?
Yes, ma'am.
Yes, ma'am.
Good.
Yes, ma'am.
So now very simple set theory definition of union and intersection of two. If you are learning graph theory, so you should know maybe somewhere you can get G, if there are two graphs, G1 and V1, just G1 and G2, and with vertices set V1, V2, edge sets V1 and E1 and E2. So what do you understand by union of two graphs? Union of two graphs means you are going to take union of these vertices sets and those edges sets. Okay, so that will be the, and name of another graph is means a new graph is going to be created. Okay, with the help of G1 and G2 means we are going to merge. So we are merging V1 and vertices set and edges sets. So that is new graph G3 is going to be created and vertex set with V1 union V2. Union everyone is knowing the set theory. That's why I am not put in this topic. Because if you are learning set theory, why I am going for 9th, 10th, 11th, 12th revision. So in prerequisites, I put here set theory knowledge like that. So means here take all the vertex set and take all the edges in the union. So that is the example of union of two graphs. And now what is the meaning of intersection of two graphs? Means this is like a intersection of two sets. So intersection of means G1 and G2 vertex sets intersection means जो vertex दोनों में common है that you have to take in the new graph. That is the G1 intersection G2. It is denoted by G4. Okay. So and which those edges if common are in G1 as well as in G2, then you have to take in the intersection. Intersection means common thing. Always get definition with name. So if there are two graphs G and H, so students here G union H is formed by using this definition. Now you try to get how this has been formed with my definition what I given. And G intersection H, this is a new graph G3 as I given the name, and this is a new graph G4. And it has been formed by using the set theory definition, union and intersection. It is very easy. Okay, try to get. You can see here vertex set 1, 2, 3, 4, 5. In H, same vertex set. Okay, 1, 2, 3, 5. Edge set E. Here you have to give the name E1, E2, E3, or I think don't give name, otherwise it will be confusing. So here student, you can see here 1, 5 is present there. You have to put all things you have to consider. Whatever in G and whatever in H, all points, all phenomena you have to consider when you are creating G union H. देखो 1, 5 is present there, it should be here. 1, 2 is present here and here common, so you have to take. Those you have to take also common things, but you have to take another thing also. If you see 2, 4 is here, 2, 4 you have to take. If you see here 4, 3 is connected, you have to see. Nothing you have to leave here. Everything you have to consider. So whatever in G1, whatever in G2, you have to consider for G1 union G2. And 1, 4 is there. 2, 5 is here, not present, and 2, 5 is present here. So then you have to take 2, 5 edge. Are you getting? Because for union, you have to consider for G properties a number of edges as well as number of edges of H. You can see vertices are same. Here you can see G intersection H, common things only, common edges. First of all, make vertices 5 common. 1, 5 is here, 1, 5 is not there, so no common edges. 1, 2 is present here, 1, 2 is present here. Yes, you can take 1, 2 because 1, 2 is common for both. Edge, 1, 2 is edge. 1, 4 edge is here, 1, 4 edge is here. You can take here. 2, 3 edge is here, 2, 3 edge is not here. So you can't take. 3, 4 edge is here, 3, 4 edge is common here. So you can take. 2, 4 is not. Anything else? Nothing. Yes, 2, 4. I have not mentioned here. So you can see only common edges I have considered here, and all the vertex set union or intersection vertices are common, so you can take. And student, if in the case if both are having dissimilar edges, vertices means number of vertices यहाँ पे ज़्यादा हो गए, suppose 6 है for that type of example. So here you have to include 6, but in vertex set it will be not common, so you should not include 6. Are you getting my point? Intersection means vertex set intersection and edge set intersection. So here both edges are same, so I have taken. Got it? Can I proceed to next topic? Anyone?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
More examples, but I will upload. I think topic is clear. What is the time? Yeah, we have time. Representing graph in computer memory. Okay, I'm able to prepare graph with my pen and paper. So how we are going to read everyone, and then we are going to the way how to feed these graphs in our computer memory. So there is a standard way of maintaining graph in the memory of computer. This is called sequential representation of graph. Means by using adjacency matrix concept. We have to understand the adjacency matrix concept like 0 and 1, and then we are going to use, we are going to feed these graph in our computer. We can feed these graphs in our computer memory. So graph with m vertices and n edges, that is one things also. I want to tell you here matrices, and why we are feeding, because if we are only giving the data, we are giving input to the computer memory. So that is okay when graphs are very simple, means not complicated. But suppose there is 100 of vertices and 100 of edges and 200 of edges, then how you are going to give inputs to by using programming? That time you have to convert this graph into the form of matrices. That form is known as adjacency or adjacency matrix of that particular graph. Okay. And if m vertices and n edges are graph and graph is dense, so matrix will be of order n square. That is the definition, but I think I will not focus here. I will, because we have less time. So we'll focus how to create different type of matrices. So there are two matrices we can create for uses of computer. One is the adjacency matrix and another is the incident matrix. Adjacency matrix are based on the just listen, adjacency matrix based on the adjacent edges. Like if edges are adjacent to two vertices, so number will come 1. If not adjacent, number is 0. Everyone is knowing computer understand only the language 0 and 1 binary number. That's why this structure you can see. So here adjacency matrix of graph, let G is a graph with vertex set and edge set, n vertices. Okay, so n cross n matrix. So n cross n, I am creating here square matrix is an adjacency matrix of the graph if and only if ai comma j is 1 for ij belongs to E. Why? What is the meaning? मैट्रिक्स का अगर हम 2,3 देख रहे हैं, मतलब सेकेंड रो थर्ड कॉलम. ओके, सो वहां 1 प्रेजेंट होगा when 2, 3 edge will be there in the edge set. Are you getting, student? But if you are not going with definition, it's okay. Just listen to me. If edges is there between 2 end point, so there you have to write suppose 2 and 3. So 2 and 3 have edges, have edge. You have to mention 1 there in the matrix. If suppose there is an 1 end and 2 and 4 have an edge, you have to mention that 1. 3 and 4. So here 3, here 4, here 3 and here 4. So 3 and 4 don't have an edge. So you have to mention beside that 0. So 1 for yes edge is present, 0 for edge is not present. That is very, very simple. Try to understand, this is a graph, okay? Number of vertices you can see. So what we have to do, we have to create a square matrix. Okay. So square matrix, how many nodes? 1, 2, 3, 4 up to 9. 1, 2, 3, 4, 9. You have to write here in row wise and as well as for column wise. So here you can see 1 and 2. Between 1 and 2 vertex is there. See student, if loop was present here, then we can put 1 and 1. There is a 1 edge. That is a loop. Okay. For loop, we can put 0 here. So this definition is applicable for multigraph also. So here between 1 and 2 edge is present. So 1 and 2 edge will be present as well as for 2 and 1 also. So आपको साथ में ही करना है. Because 1 and 2 direction is not here. So 1 and 2 edge is present here. Between 1 and 2, 1 is present here. So between 2 and 1 also you put 1. Concentrate student, only for 1 minute you are going to learn. So 2 and 3 edge is present there. So 2 and 3 and 3 and 2. Before that you have to put 1. 3 and 2, 1 is here and 2 and 3, 1 is there. In the same way 3, 4 and 4, 1. So 3, 4 and 4, 3. I think you got it. 2, 6, 1 is present here. 6 and 2 you also put 1. So 1 for edge presence, 0 for edge absence. Clear everyone? I don't think everything I need to mention here, everything.
Yes, ma'am.
Good. Not getting bored, right? ऐसा तो नहीं लग रहा है, only just listening because in tutorial you will do. So, okay, I'm giving you a concept. See how I created this? This is a graph and I have created this adjacency matrix for this particular graph. Is it okay? Actually, this will be converted into 1. This is showing only number of edges. 1, but when we are putting in computer memory this data, we have to convert into the 1. Only for presence and absence. But 3 is counting here because if you put any programming here to convert, so they will, that programming will convert into 3 because 3 times of between A and B. Suppose here A, B, C, D. A, B, C, D. Okay. So this is 3 showing here between B and A. There are 3 number of edges because you have put all the programming you have created means A and B. If edge is there, so it should count 1. So like that. So it is, we are counting manually. So we are going to count 3 here. Okay. But edge is there present between A and B. So computer will count 1 here because A and B, between A and B, 1 is present there like that. For loop also, if computer is, if I'll start counting, so I will count because one edge is from here A and D. So where is A and D? Not here. Or C I am looking for. Yeah. C and D. So for C to C also student, you can see for loop. I wanted to tell you one example for loop also. So C to C only between B to B 0 is there, between A to A 0 is there, between D to D 0 is there, but between C to C, this is the C and this is the C. There is a 1 because C is having loop. I hope you got it.
Ma'am, so the
in exam you have to do like this.
Ma'am, so the statement that is written above, it's wrong.
Where?
Ma'am, the diagonal entries of an adjacency matrix are 0.
This a graph has no. No, this is not wrong. I am saying if okay, I have not read. The diagonal entries of an adjacency matrix are 0 when the graph will have no edge with both end the same. Okay.
Okay. Okay, ma'am.
That is, but I will explain later. I don't have example of that.
Ma'am, for the loop, we count 2 times, right?
Loop, if from C to C, I am counting here if edges between two C and D and edge is there, so we'll count 1. So here I am telling you for loop is kahan par hai? Loop is here at C. C to C and edge is there, is it? So that's why 1 is present here. Got it?
So, ma'am, do we have, when we have an exam or a question, do we need to enter 3 or whatever are the number
Yes,
of
you have to
edges
do this
between?
because we are doing manually. That's why I'm telling you. In exam, you have to do like this.
Okay, ma'am.
Okay? But in programming, when you will do now, it will be converted into 0 and 1 only. So that is a later part. Okay, now you student, you can check for this. I will upload. At least up to this topic, I will upload by today. What is the meaning of incidence matrix of a graph? Incidence matrix is showing how many times that particular edge has been incident on that particular vertex. That is between vertices and edges. So if you see what you have to do for incidence matrix, if vertices, whatever vertex sets elements are there, you have to mention here. And if from V1, E1 is passing, then you have to put 1 here. From V1, E2 is passing, then you have to mention 1 here. So this type of incidence matrix also you can create here for this purpose. E3, from V1, E3 is creating or E3 is passing, no, so it is 0 here. From V1, E4 is passing, no, so 0 here. E5, E6, like this. From V2, you can see E3, E6 and E4. E3, E6 and E4. And for others, rest of the vertices, 0. Like that. This is the concept of incidence matrix. So it is showing the incident of edges on the particular vertex. That is the name here. If you want to know how many edges are incident on the vertices, so then you can see the incidence matrix. Students got it, and please create this E1, E2, E3, E4, E5, E6. Okay, E7, up to E7. We have time 5 minutes. 2 minutes. So student, can you solve this problem? Just note down or click the picture. I have
Yes.
some more pictures for your example, for your exercise. Incidence matrix of the given graph. So you have to find, you have to show the incidence of the edges on the particular vertex. These examples also you can take for your problem solving.
Ma'am, so an
Yes.
incidence matrix does not have to be a square matrix, but an adjacency one has to.
Yes, because here any vertex can have number of what you can say, number of incidence of
Edges.
edges, right? That is the reason.
Right. Okay, thank you.
And students, I think in tutorial class, I heard one student was curious about to find determinant of higher order matrix, right? So actually, I want to take your MATLAB class when you are free, because this is the time when I can take. So that is very easy to find, to write matrix, or it is very easy to find the determinant or inverse of any matrix. That is within a second you are going to get, student. So I want to show you here when one day we get time, and I will complete matrix portion with MATLAB also. Okay, so how matrix is created, and if within a second if you see, so you can get inverse of that particular matrix also. So see how, I think my screen is visible. So how
Yes, ma'am.
fast I am
Yes, ma'am.
creating the matrix,
Yes,
and
ma'am.
how fast I am getting the inverse of the matrix if you want determinant of that matrix, whatever 3 cross 3 or 100 cross 100. But maybe little bit determinant of this matrix A is I have shown here also. So minus 36 or adjoint of that matrix if you want to find. So everything you can calculate. Maybe if I forgot any formula. So for adjoint whatever is there. Okay, so I think anything else I need to for adjoint. So that is means if by using a software you can solve matrix and you can check your result also. That is very simple. So that's why MATLAB is available here. That's why I'm telling you here. So student, till whatever topics are there, you have to revise and then you have to come in the next class because maybe I can use any topic here. So next, so many topics are there, some formulas are there for graph theory, and it will take this week full or maybe next week. So be ready for next.